So we're going to do some Unit 2 assessment review by going through some of our questions here. Now, it's going to be quick so that we have enough time to do things, okay? So we have our first question here, and it says, identify the angle pairs that match each named relationship. Identify the angle pairs that match each named relationship. Okay, so we have this guy here. We have our two lines cut by this transversal. We have our angles here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And we want to name the angle pairs that match each angle relationship. Okay, so remember, corresponding angles, that's our first one. Corresponding angles are angles that are in the same corner, okay? So I want you guys to try to do these with me, but for the sake of time, this is more of a review. So remember, corresponding angles are angles that are in the same corners or the same positions in each quad here, okay? So we are going to essentially name all of the ones that match, okay? So remember, when we talk about these angle pairs, one angle comes from the top quad or top 4, one angle comes from the bottom 4. So you're pairing up one from each of these. So same angle or same corner here, angle 1, same corner here, angle 5. So corresponding angles would be angle 1 and angle 5. That's one pair, okay? And then over here, when I look at angle 2 is in the top right, angle 6 in this quad, right? We're looking at the quads here, here, and here. So 2 and angle 6 here, yes. Okay, I have 2 more. The bottom left corner, that's angle 3. Bottom left corner, that's angle 7. So we have angle 3 and angle 7. And lastly, we have angle 4 and angle 8. Okay, so corresponding angles, okay, we're looking at each of these quads and we're talking about each of the corners here, corresponding, right? Meaning same position. Okay, so that's that one for corresponding angles. Let me erase these. Okay, next one, I'll do this one in red. We have alternate interior angles. Okay, so whenever we see the word interior here and here, we're talking about the angles that fall in between my 2 lines that are being cut by the transversal. So we're talking about this space here. Okay, that's the interior. Okay, so when we say alternate interior, we're saying alternating along the transversal, so on opposite sides of the transversal. Now, remember I said that with these pairs, one comes from the top quad, one comes from the bottom quad, okay? So 3 and 4 might be alternate interior, but they're from the same quad. So they can't be alternate interior pairs. But angle 3, alternate side, we have 4 and 6. 6 is from the other quad. So angle 3 and angle 6. They are interior of my 2 lines here and on alternate sides of my transversal. Okay. And lastly, I have 4 and 5. Angle 4 and angle 5. Okay. So 3 and 6, 4 and 5. 5 is our interior. It's between our 2 lines. Okay. Now, if interior means between the 2 lines, then exterior means outside the 2 lines. Okay, so now we're looking at angles 1 and 2, and 7 and 8. That's the alternate exterior angles. Alternate still means opposite sides of the transversal, okay? So again, one angle needs to be from the top quad, one angle needs to be from the bottom quad. So if I'm looking at angle 1 here, okay, I can't look at angle 2 as its alternate exterior angle pair. I have to be looking at 7 or 8. So then I ask myself, which one of these angles is on the opposite side of the transversal from angle 1? Well, if angle 1 is on this side, then the other angle, the alternate angle, has to be on this side. So it'd be angle 1 and angle 8. Okay. Similarly for angle 2 here, alternate side of the transversal here, that would be angle 7. So angle 2 and angle 7. Okay. And then we come to consecutive interior angles. Okay. Now interior brings us back in between my two lines here, my two lines cut by a transversal. But now instead of alternative, we have consecutive. Okay, this is also known as same side. That's another phrase for it. So consecutive is the same thing as same side. So now we're looking at the same side of the transversal. So if I'm looking at angle 3 here, okay, again, this angle 3 is from the top quad, so I'm looking at 5 or 6. Which one of these, 5 or 6, is on the same side as angle 3? That'd be 5. So my consecutive interior angle is angle pair. One of them is angle 3 and angle 5. They are on the same side of the transversal now. Okay, and similarly on this one, we have 4 and 6. So angle 4 and angle 6 are also same side or consecutive angle pairs. Okay, so interior exterior refers to either between the lines or outside the lines, and alternate or consecutive refers to either on alternating sides of the transversal or the same side of the transversal. The words tell you where to look, honestly. Okay. All right. May I move on? Okay, let's see here. I think I'm gonna have to.
Marielle says yes. Savon says yes.
Okay.
Paula says yes.
There we go. All right. I was having a hard time actually moving it along. Okay, question number 2. Using our angle pairs. Okay. So we have lines A and B are parallel. So these guys are parallel. Remember the symbol for parallel was our little arrows here. We can do the double arrows just to make it look a little different than the side arrows. So lines A and B are parallel. Both lines are intersected by transversal P. So this guy here, as shown below. What is the value of X and the angle? Okay, so they want to know the value of X and then the value of the angle itself. Okay, so if you remember, okay, our angle pairs, when our lines were parallel to each other, our angle pairs were either congruent or supplementary. Okay, so they were either congruent or supplementary. Okay, now most of our angle pairs were congruent when our lines were parallel. So our corresponding angles, our alternate interior angles, and our alternate exterior angles were all congruent when our lines were parallel. The only one that was supplementary was the consecutive interior angles. Now, the reason why we need to know this is because if I take a look at these two angles here and here, if I can identify what type of angle they are or what a kind of angle pair they are, then I can set up an equation. If they're consecutive interior angles and they're supplementary, then I can add them and set equal to 180 degrees. But if they are corresponding alternate interior or alternate exterior angles, then I just set them equal to each other because they're congruent. So the question here is, what kind of angles are these two angles? What's the angle pair? Are they corresponding angles, alternate interior angles, alternate exterior angles, consecutive angles? So you can start by looking at, are the angles inside or outside? Are they between my two lines or outside my two lines? Okay, we can see that they're both outside my two lines. Okay, so they're not here, so they're outside my two lines. So that means alternate interior is out and consecutive interior is out. Okay, now if they're both outside now, then I look at alternate exterior or alternate or corresponding. If they were corresponding, they would be in the same side in the same corner. So this would be here also, or this would be here also, but that's not the case. Oops. I have two angles that are outside, so they're exterior, and they're on opposite sides of the transversal. They're alternate. So I have alternate exterior angles. Okay. Okay, I have alternate exterior angles. So good job, Gabriel. Good job, Zivan. Destiny, you almost had it. So if they're alternate exterior angles, then that means I can set these angles equal to each other. So I'm going to take 2x plus 38. I'm going to set it equal to 3x minus 9 because alternate exterior angles are congruent to each other. And then I solve for x. 3x is bigger than 2x, so I'm going to move the 2x over here. Okay, so that's going to be 38 is equal to 3x minus 2x is x minus 9. I'm going to add 9 to both sides of the equal sign, so I can move the 9 now. Okay, remember we want the x's on one side and the numbers on the other, right? So then this is going to be 38 plus 9 is going to be 47 is equal to x. Okay. So if x is equal, so that's my value of x right here. That's the value of my x. And then to get the value of the angle, I can take any one of these and plug x into it. So let's say I want to do 3x minus 9. Doesn't really matter. So instead of the x, I plug in what I found from the value of my x, which was 47. So 3 times 47 is going to be 141 minus 9. Okay, and that's going to be 132 degrees. So that's the value of the angle. Okay, that's a degree, not a 6. Okay, so that's 132 degrees there. If I wanted to double check my answer, I could also plug it into this guy and confirm that it's also 132 degrees. Okay, so the whole idea of figuring out what angle pair it is really to know, do I set them equal to each other or do I add them and set them equal to 180, right? Are they congruent or supplementary? And as you can see, most of them are congruent. So as long, if you rule out consecutive interior angles, then you're kind of almost gonna be setting them equal to each other.
Can I ask a question?
Absolutely.
As a way of remembering this, isn't it easy just to remember that they all have the angle pairs are congruent for all of them except for one, consecutive interior angles, which is supplementary.
For the most part, yes.
Okay.
For the most part, absolutely. Except if you also remember that if we bring in vertical angles and linear pairs, then linear
Vertical
pairs,
angles are congruent too, but not
vertical
linear
angles are
pairs.
congruent, but linear pairs are also supplementary.
Right.
So the majority of them are congruent.
Right.
You just need to watch out for consecutive interior angles and linear pairs. Yep.
You know, and I think that the figure often gives you a clue. You can look at those two angles and look at them and say, gee, they kind of look the same.
Yeah, they're both obtuse.
They're both obtuse, right? They both look like the same angle.
Yeah,
So,
like
you know, they are.
this guy and this guy are both acute. So are this guy and this guy,
Mm-hmm.
right? This is obtuse and this is obtuse. So that means these guys will be congruent to each other. These guys are congruent to each other because they're corresponding, right? So there's a lot of congruence happening here. A lot with the parallel lines. All right. So let's move on to question number 3 now. Okay. Question number 3. Oof, is a proof. Yeah. But we can do this. I promise you. Okay. So we want to prove that we want to prove the consecutive interior angles theorem. So if you remember, the consecutive interior angles theorem says that when we have parallel lines, consecutive interior angles are supplementary. That's our consecutive interior angles theorem. Okay. So we want to prove that consecutive interior angles are supplementary. In this situation, angle 1 and angle 2 are the consecutive interior angles. Okay. So we want to show that angle 1 plus angle 2 is 180. Okay. So they have the proof practically done for us. We just got to fill in some of the reasons here. Okay. So we're given that P is parallel to Q, line P is parallel to line Q. That's our given. The next statement they make is angle 1 is congruent to angle 3. So they're saying that angle 1 is congruent to angle 3. Okay. Well, if my lines P and Q are parallel, angle 1 and angle 3, they are alternate interior. Oh, no. Hold on, technical difficulties. Sorry, there we go. My apologies. Angle 1 and angle 3 are alternate interior angles, which means that with parallel lines, they are congruent. So that means we can make the statement that angle 1 and angle 3 are congruent because of the alternate interior angles theorem. Okay. So that tells us that angle 1 and angle 3 are congruent. And then they make this statement here. The measure of angle 1 is equal to the measure of angle 3. This is definition of congruent angles. So if you remember, guys, congruence means that the shape and the size are the same. Measure means that the value and the measurement of the angle is the same, okay? So this is almost identical statements, although over here in geometry, when we say congruent, we're talking about the shape and the size. When we want to talk about the numbers and the math of it, we talk about measurement. So we can go back and forth between measurement and congruence, okay? And then they make this statement, measure of angle 2 plus measure of angle 3 equals 180 degrees. Well, angle 2 and angle 3 are these two angles here. What reason can I say to say that they would add to equal they would add to equal 180 degrees? Okay, what reason would I have? If you look at the two angles, what do you notice about those two angles there? Okay. Hopefully, you're able to notice that they are a linear pair. Remember, linear pair are two angles that are adjacent and they create a straight line. So angle 2 and angle 3 are a linear pair, which means they are supplementary. So I can say that they add to equal 180 because of definition of a linear pair. Okay. And then look what happens here. I have angle 2 plus angle 3 is equal to 180, but then that changes to angle 2 plus angle 1 is equal to 180. Angle 3 changed to angle 1. How was I able to do that? Because measure of angle 1 is equal to measure of angle 3. So all we did here is we substituted measure of angle 1 in for measure of angle 3 because they're the same thing. So this is just substitution. Oop, I didn't need that S there. That's just substitution. Okay. And so lastly, if angle 2 plus angle 1 is equal to 180, then that means that angle 1 and angle 2 are supplementary angles. Okay. So we can literally say definition of supplementary angles. Definition of supplementary angles. Because that's what supplementary angles means, right? Two angles that add to 180 degrees. And of course, I can't write definition clearly. Let me rewrite that for those of us that are a tad behind. Did it again. Okay. All right. Okay, let's move on to our next question. I gotta check the time here. All right, question number 4, y'all. Okay. Alicia claims there is enough information to verify. Here, let me clear this slide. Clear all, and please go back. There we go. Okay. All right, Alicia claims there is enough information to verify that M is parallel to N. George disagrees with Alicia. So, so I didn't put the statements below, but we see that we have this angle congruent to this angle, right? By the angle markings. If they have the same number of arcs, then they're congruent, okay? What kind of angles are those? Okay, if we take a look, this angle and this angle, they are outside my two lines here. So they're exterior. They're also on, here's my transversal. They're on opposite sides of the transversal. So they're alternate.
Yeah, but is any information given?
I'm sorry?
Is any information given about M and N?
The lines, no, we're trying to show that they're parallel.
Okay, I just don't see a lot of
what we are
marks
getting,
or tick marks or anything else like
we don't
that.
have tick marks, but we have those.
We have the red. I thought you marked that in. The red was already there.
No, the red was there.
Got it. Okay.
Yeah, the red was there.
Got it.
Right. So we can see that because these two angles have the same arc marks, same number of arcs, that they are congruent. So this angle is congruent to this angle. Okay, let's call this angle 1 and angle 2. Okay, so we see that's what's given to us. Angle 1 is congruent to angle 2 because they have the same arc marks. So what I'm showing is I'm trying to determine if these two angles have any kind of relationship, if they're an actual angle pair, right? And so I start identifying where they are in terms of my two lines that I'm trying to show parallel and my transversal. So they're outside my two lines, which means they're exterior. They are on alternating sides of the transversal, which means they're alternating. So angle 1 and angle 2 must be alternate interior angles, right? So if I have alternate interior angles that are congruent to each other, as given here, then I can say that my lines M and N are parallel. Because if alternating interior angles are congruent, then the two lines are parallel. This is the converse of the alternate exterior. Oh, I put interior there, huh? I meant exterior. My apologies. Although interior is also true. Dang it, did it there too. Converse of the alternate exterior angles.
I almost did the same thing earlier, I
Theorem.
swear.
Yeah. Okay. So if the angles are congruent, then it also does the opposite, the lines are parallel. If the lines are parallel, then the angles are congruent. If the angles are congruent, then the lines are parallel. So they go back and forth. Okay. They do go back and forth. Okay. Number 5 is a very similar question. So I'm going to move on to number 6 for the sake of time, y'all. Okay. So apologies for that. We're just going to move straight on to number 6 because number 5 is a very similar question to number 4. Okay. Okay. Let's take a look. Oh, now we're into transformations. Chapter 4. Yay. All right. It says triangle ABC shown below is translated to triangle A prime, B prime, C prime by the transformation rule xy goes to x plus 3, y minus 4. Okay. So if that's our transformation rule, we can do this by counting because it's a translation. Okay. Nope. Hello. It's a translation. Or we can do this algebraically using our points. So first things first, I got to figure out where A, B, and C are. So if I want to know the coordinates, right, I can do this algebraically. So I just need to plug in each X into here, each Y into here to get me my transformed point here. First, I need those points. So let's take a look. A looks to be at 2 and 5. Okay. B is at 3 and 1. And C is at -3 and 2. Okay. So when I come here to get my transformed points, each one of my x's is going to be added by 3. Each y is going to be subtracted by 4. So plus 3 minus 4. Plus 3 minus 4. Okay. So that's my rule. That's what I'm using from right up here. So then I just take each one of my points. A goes to A prime, B goes to B prime, C goes to C prime. So I take each one of those guys and I plug it in. So for A, my X is 2, my Y is 5. So 2 is going to go here, 5 is going to go here. For B, X is 3, Y is 1. For C, X is -3 and Y is 2. Okay, so then I just go through and I simplify these guys. So then A prime is going to be 2 plus 3 is 5. 5 minus 4 is 1. There's my A prime. B prime, 3 plus 3 is 6. 1 minus 4, -3. And then C prime, -3 plus 3, 0. 2 minus 4, -2. So the coordinates of my translated triangle A prime, B prime, C prime are as follows: 5, 1, 6, -3, 0, -2. And I could plot those if I wanted to. So 5, 1, here's A prime, 6, -3, B prime, 0, -2, C prime. Don't mind triangle shape. I can't draw well on this pad. Okay. Okay. Number 7. Similar idea, but now we're looking at a reflection. Oh, I just went to question number 8. Here we go. Okay. 7. If triangle MNO is reflected across the line y equals x, what would be the coordinates of triangle M prime, N prime, and O prime? So the line of y equals x is this line right here. Oopsie, go away. Okay, this is the line right here of y equals x. Okay. The rule for the line reflecting across the line y equals x is that each point of xy goes to yx. It switches. Okay, that's the rule for reflecting across y equals x. It just becomes yx. So again, I need to know the points for each one of these so I can figure out the reflected points. Okay, so M looks to be at -3 and 7. Okay, N is at -2 and 4. And O is at -6 and 1. Okay. So if the rule is that each one of these points just flips, that means I'm going to take each one of these and just flip them to be the reflected line, a reflected triangle across the line y equals x. So M is at -3, 7, so that M prime is at 7, -3. Basic, literally, you switch them. N is at -2 and 4, so N prime is at 4 and -2. O is at -6 and 1, so that means O prime is at 1 and -6. So remember, the signs don't change, nothing changes other than the x becomes a y, the y becomes the x. So M prime is at 7, -3 now. Here's M prime. N prime is at 4 and -2. This is N prime. O is at 1 and -6. This is O prime. There you go. Not the best triangle that I've drawn. Oh, that's actually better though. That's it. That's all there is to it. Just remember the rule and apply it. Okay. So next one, number 8. If quadrilateral ABCD was rotated 270 degrees counterclockwise about the origin, what would be the coordinates of quadrilateral A prime, B prime, C prime, and D prime? Okay, so we have 270 degrees counterclockwise about the origin. So remember, counterclockwise means this way. Okay, so 270 degrees means 90, 180, 270, or yeah, 270. So it's going to end up right over here. Okay. It's going to end up right over there. And the rule here is going to be xy becomes negative y, negative x. That's the rule for a 270 degree counterclockwise rotation. Xy becomes negative y, negative x. So not only does the y and the x switch, but they also change their signs. Okay, so once again, we are going to figure out what the points are for each one of these.
Is that rule only good for counterclockwise 270?
Yes.
Okay.
Yeah, you guys have a nice little, remember the nice chart that we made for our rotations, where that has all the rules all the rules summarized for us. Okay, you can always have that rule out, like you're at home. So your tests are open notes, so you can use it. You just got to remember the rule, right? So A looks to be at 2, 2. B is at 6 and 3, so 6, 3. C is at 7 and 6, so 7 and 6. D is at 1 and 5. Okay, so each one of these, I'm going to write the points here. 2, 2, 6, 3, 7, 6, and 1, 5. Okay, so each one of these is going to be flipped and we change the sign. That's the rule for the 270 degree counterclockwise rotation about the origin. So I'm going to flip each one. So this one is actually nice because it's 2 and 2. So it's going to be 2 and 2, but since they're both positive and I need to change the signs, now it's going to be -2 and -2. Okay. For B, they're a little different. So first I'm going to flip their places. So I have a 3 and a 6, but they each need to change their sign. So this is +3, it becomes negative. +6, it becomes negative. Okay. For this one here, 7 and 6. So switch places, 6, 7. Positive becomes negative. Positive becomes negative. Okay. And then switch the places again, 5 and 1. And again, positive becomes negative, positive becomes negative. Okay. How do you know it has to be negative? Because the rule, it doesn't have to be negative, Destiny. It has to change its sign based on the rule. Okay. So if there's a negative there, the rule says that it changes the sign. Now, since all of these were positive, that means they're all going to become negative because.
Can I emphasize that point? That negative does not mean the answer is negative. That negative in the rule means change the sign.
Right. So if I had started with a negative number in the original, I would change it to be a positive. If it tells me to change the rule, like to change the sign. Okay. A good question, Destiny. Very good question. Oh, no. Hello. There we go. Okay. So it's so important that you know the rules, guys. It's so important because it's literally your guideline to what to do. It's literally telling you exactly how to get the answer. Okay. Let's go to question 9. Another one. Yep. Okay. Question 9. It says triangle ABC, shown below, undergoes a dilation by a scale factor of 2 through a center point at the origin to produce triangle A prime, B prime, C prime. Okay. I have a few questions. It says, what happens to the length of each side? Is this an enlargement or a deduction? And what are the coordinates? Okay. So if my scale factor is 2, that means that my sides are going to double because the scale factor is 2. So if the length the length of each side doubles because my scale factor is 2. If my scale factor was 3, it would triple. If my scale factor was 5, then it would be times 5, right? If my scale factor was a half, then that means it would be cut in half, right? So whatever your scale factor is, that's what it's doing to your figure. It's either doubling it, tripling it, halving it, whatever your scale factor is, that's what's happening to the size of the figure, right? So if the size of the figure is getting doubled, then that means the length of each side is getting doubled, okay? So if I have a scale factor of 2, that means I'm doubling things, which means yes, I have an enlargement, okay? I can also see that because my scale factor is greater than 1, right? If my scale factor was less than 1, then it would be a deduction. That means I'm scaling things down, okay? And then of course we have, what are the coordinates of A prime, B prime, C prime? So if you remember, finding the coordinates for a dilation is actually really easy. It's taking your, the rule is always the same. You multiply your coordinates by your scale factor. Oops, hold on, I wrote that wrong, don't copy that. And I want to use a different color. And let's use a more vibrant color. Let's go with red. Okay, so X, every single one of our points gets multiplied by our scale factor. Okay, so to find A prime, I multiply, so in our case now, our scale factor is 2. So it'll be 2 times X and 2 times Y. So first I need to find my points here. A is at 1, 1. B is at 3, 1. And C is at 1, 4. Okay, so that means each one of these, we have 1, 1. So we're going to be multiplying our X and our Y to our scale factor here. Okay, so I have 1 here, 1 here, and we're going to multiply by our scale factor. For my B, I have a 3 here for the X and a 1 for the Y. And then over here for my C prime, I have 1 for my X and I have 4 for my Y. And so what I'm going to do with those is I'm going to come in and I'm going to multiply by my scale factor, which is 2. So 2 times there, 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 and 2 times there. Okay, so my dilated coordinates will be 2 and 2. Over here, it'll be 6 and 2. And over here, it's going to be 2 and 8. So when I graph those, I have 2. Does this graph seem off to you guys? A little, right? Okay, I'm not tripping. Okay, so 2 and 2. That's going to be A prime. 6 and 2. That's going to be B prime. And 2 and 8. That's your C prime. Damn it. There we go. There you go.
Are you using that same tablet that I shared with you?
Yeah.
You are better at it than I am, I swear. It's not that easy.
It's not. No, that's why these
Yeah.
lines end
You
up
know, you
being
make
really
it look
difficult.
easy though, except for the line.
Yeah, I was like, I should use this tablet a little bit more often. All right, guys. So that's our dilation. Okay. And then we have one last question to look at, and that would be our question 10. Okay. So for question 10, I have some options here. The key for question 10 for this one is to make sure you are looking from the correct figure to the correct figure. So you want to make sure you recognize which one is the pre-image, which one is the image. Okay, so that's going to help you determine what happened. So it says, which of the following list, okay, of transformations accurately maps PQRS to P prime, Q prime, R prime, S prime, as shown below. Okay, so it's important to recognize which one is PQRS and which one of these is the prime, so pre-image and image. So PQRS is our blue one here. And we can see that because of the points, right? They don't have primes there. So PQRS here, this is our pre-image, okay? And then over here we have P prime, Q prime, R prime, S prime. Well, that's now our image. That means we went from the blue one to the green one. So we started at the blue one and we went to the green one, okay? So what's the first thing that you notice about them that you should notice about them? The green one is smaller than the blue one. So we started big and we got small. Okay, the only transformation that does that is a dilation, which we have here. Okay, but it's a dilation that's a reduction or deduction, right? It's a dilation that is a reduction. So we are looking for scale factors, right? So a reduction means our scale factor is less than 1. So if I take a look at my options here, it's a dilation with the center at the origin and a scale factor of 1/2. That's a possibility because 1/2. Dilation with the center at the origin and scale factor of 1/2. That's also a possibility, okay? So 1/2 and 1/2 are definitely possibilities because my scale factors are less than 1, which means we got smaller. Dilation with the center at the origin and a scale factor of 2, no. Okay, we had a reduction, not an enlargement. That means this is definitely not an option. Dilation with a center at the origin and a scale factor of 2, again, not an option. So I've just cut my choices by half. Okay, so the next thing is this. It's followed by, let's keep reading. Okay, followed by a reflection in the x-axis. Okay, or followed by a horizontal translation 2 to the right and a vertical translation 4 down. Okay, so one thing you have to recognize is that if we had done a reflection, the shape here, right, would be flipped. It would look like it had been mirror reflected. But if I take a look at my shape here, I see that this point P is still pointing at the bottom here. If I had a reflection, this would look more like something like this, because I would mirror reflect it across my x-axis. So it would be a mirror reflection down. Okay. Instead, what this looks like is it just looks like it's been moved down. So I have a translation, not a
Yeah, when it just moves, that's a translation.
yeah, when it's just a slide, or you just moved it down. There's no rotation of the direction it moves in. There's no mirror image of it, right? A slide is just a slide. It's just a translation. Okay. All right. So what I'm going to do now, I'm going to stop. Clear that. We're going to stop annotating. All right. And what we're going to do is I want to show you guys. So I want you to complete the Unit 2 assessment. Okay, I want you to complete the Unit 2 assessment as homework. And I know that's weird to say. I want you to take a test for homework. Okay. And this is what I'm going to do. Okay. However many points, you can earn up to 10 points on this. However many points you earn on this Unit 2 assessment, I will add to your Chapter 4 test. Look at that. Miss K gave you another opportunity to improve your grade. However many points that you get on the Unit 2 assessment, this one right here. Okay. Ooh, let me publish it so you can access it. My apologies. Okay. However many points you get there, I will be adding to your Chapter 4 test grade.
So this is extra credit.
Shh, don't tell them that.
Okay, sorry. Yeah, I forgot. My bad. No extra credit.
Yeah, this is a way for them to raise and get bonus points on their test. That's what this is. But it essentially extra credit. So